So this is problem number 2. I realized after I did problem number 1 that Pearson probably wouldn't want me showing all their problems to the whole world on YouTube, which is what I was going to do. And I don't want to be sued or anything like that. So I'm not going to show Pearson problems. These are not Pearson problems. These are problems that we are just doing because they're problems. So number 2, right? This time we have the same situation, except our rod is an inductor, right? Which means it doesn't have charge that is easily to spread around. Its charges are kind of fixed in place. So part A, or part 1, or whatever Pearson doesn't call it. So if Pearson calls it A, we'll call it 1. Part 1 is what is the, if we bring a negatively charged particle, or sphere, if you will, near end A, what kind of reaction do we get? Right, so we bring charged particle close to end A, what happens? And we should see, I just walked off the camera, what we're going to end up with is a weak attraction. Now, why is it a weak attraction and not a strong attraction? In the conductor, we got a strong attraction because what we were looking at, right, when we brought the negative particle close, all the electrons shifted to the other end. That left a massive amount of negative charge here with a massive amount of positive charge over here. And that massive amount of positive charge was able to strongly attract with the negative charge. Now, because we're working with an inductor, these electrons can't shift all the way over, right? They can become polarized, right? So they have a negative side and a positive side, but there's not nearly as much of a drastic shift of negative charge this way as we had in a conductor. So we end up with just a slight negative charge on the end of the rod, which is only enough to cause a slight attraction between the sphere and the rod, right? We get a slight attraction. Part 2. What happens if we take our rod that is neutrally charged inductor and we touch it with our negative charge, right? So we repeatedly bring our negative charge into contact with end A of the rod. So we repeatedly bring a negative into contact with the rod. So what we had in our first case where we were working with a conductor is that every time we touched A in the metal sphere, which was negative, negative particles would get transferred onto the rod, and then the rod would kind of spread the charge out because it's a conductor and those electrons were allowed to move around, right? So we would touch it, the electrons would spread out. We touch it again, it'd transfer more electrons, but they would spread out. And what we ended up with was the whole rod becoming negatively charged, right? In this case, because we're working with a conductor, right? How do we have the charge, or how is the charge on the rod contained, or what is the charge on the rod? When we touch it, the electrons are still transferred, but because this is a inductor, or an inductor, right? The negative particles can't flow and spread throughout. So they just get stuck, and we end up with a whole bunch of negative particles, negative, 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 negatives, right? We end up with a whole bunch of electrons just stuck on that left side, on A end of the rod. So when we look at the answer here, right, we end up with negative charge on A, and that charge doesn't get to spread over to B because it's an inductor. So this charge on B stays constant, what it was before, and B was neutrally charged. So B remains neutral. So A becomes negatively charged. That negative charge doesn't have the ability to spread throughout the rod, so we end up with just a negative charge on A and a neutral charge on B. And then part 3 here. How does end A of the rod react when the ball approaches it after it has made several contacts? Well, that I hope should be fairly obvious. We have a negative being brought close to what is now a massively negative part of the rod, right? All that negative charge has been transferred over. So we have a negative and a negative. Negative and negative would make a strong doesn't have an A. Strong repulsion, right? They should be strongly repelled because we have a lot of charge, a lot of negative charge on A, and a negative charge right there. Negative and negative gives us repulsion. Was I not recording? Oh, I was. Whew.